Okay, so now we're going to use implicit differentiation to find the equations of the lines that are both tangent and normal to a curve at a given point. Okay, so the example we're going to do is this right here. It's kind of an interesting equation. X times sine of 2y is equal to y times the cosine of 2x. And we want to find the lines that are tangent and normal to the curve at pi over 4, comma pi over 2. That's our ordered pair. And so the tangent line, we know what that is, but let me explain what the normal line is. Okay, so here's the graph. It's really kind of interesting. All these wavy lines. Kind of looks like ripples in water here. So this is pi over 2 here. Pi over 2. So each of those is pi over 2. And each of these are pi over 2. And so pi over 4 would be like right here. And then this is pi over 2. So this is the point pi over 4, pi over 2. Okay, and the tangent line, of course, is the one that's tangent to the curve at that point. Okay, the normal line is the line that is perpendicular to the tangent line. Okay, and we call that line the line that's normal to the curve. And it does have important meanings later on. But for now, just think of the normal line as the line that is perpendicular to the tangent line. So we want to find the line that is tangent, and that we're going to do that by finding the derivative using implicit differentiation, plugging in this point, and then we'll have the slope and a point. We'll be able to find the tangent line. And then if you remember, two perpendicular lines, the slopes are related. If the slope of a line, let's say, is 3/4, let's say, then the line perpendicular has a slope of a negative 4/5. So it's the inverse. You flip the fraction and put an opposite sign. Okay? And so then we can find the equation of the normal line that way. So that's what we're going to do. Let's see if we can find these. So we're going to start by taking the derivative of both sides of this function. Oh, by the way, just so you know, I did this on Desmos, so this is kind of fun. I would bring up Desmos as you're working on the homework, and then you can actually type in the equations that you're using, and it'll bring a little more meaning behind what's going on. Okay? Kind of a fun thing. So, what I'm going to do is I'm going to take the derivative of both sides with respect to x. Okay, so it'll look like that. And now what I'm going to do here is I'm going to use the product rule, and we'll treat y as an implicit function of x. So this has like, you're going to need the chain rule when you find the derivative of this. So this is like the function x times the function sine of 2y, and sine is on the outside. 2y is an implicit function of x on the inside, and so we're going to use the implicit differentiation, same as over here. So we're gonna so let's do this here. So the derivative of the first part is just 1, so it'd be like 1 times the second function, okay, plus the derivative, or the first function, which is x, times the derivative of the second function. So that'll be derivative of sine is cosine, evaluated at 2y, times the derivative of 2y with respect to x, and that's going to be 2 dy dx. And it would look like that. And that's using the product rule on this. Now the product rule on this. So now the one function is y, the other one is cosine of 2x. And we're going to take the derivative with respect to x. So the derivative of the first function is just dy dx, times the second function, which is cosine of 2 x, and then we're going to add the first function, which is y, times the derivative of the second function. So the outer function is cosine, inner function is 2x, and we're taking the derivative with respect to x. So this would be the derivative of cosine is the opposite of sine. So this would be the opposite of sine evaluated at 2x times the derivative of 2x, which is just 2. So it would look like that. Okay, so now I can kind of maybe clean this up a little bit. This would be like sine of 2y plus, that 2 could go out over here, 2x cosine of 2y. This would be dy dx. And then this would be dy dx cosine of 2x. And then this would be minus, and then you'd have a 2y, and then sine of 2x. Okay, so it would look like this. So now bring everything with a dy dx over to one side, and then we'll bring this over to this, everything without 1 over to this side. So doing that, I'm going to get 2x cosine of 2y dy dx, and then bringing this over, minus dy dx times the cosine of 2x, okay, is equal to, now I have this, the opposite of 2y sine of 2x, and then I can bring this over to the other side, and then I get a negative sine of 2y. So it would look like that. Now I'll pull out the dy dx. Pull out the dy dx, and then divide both sides by what remains after I pull out the dy dx. So if I do that, I'll get this. Okay, so it looks like that, right? So that's my expression for the slope of the tangent line. So now what I want to do is I want to find the actual slope of the tangent line by plugging in pi over 4 and pi over 2. Okay, so dy dx at that ordered pair. Okay, so when I do that, I'm going to get negative 2 times the y is pi over 2, and then this is going to be sine, and then when I plug in x here, I'll get 2 times pi over 4, which is just pi over 2, and then this will be sine, and when I plug in the y here, I'll get 2 times pi over 2, which is just pi, sine of pi. And then all of this is going to be over, this will be 2, and then the x is pi over 4, and then this will be cosine, and then when I plug in y into here, I'll get pi, and then minus cosine, and then when I plug x into here, I'll get pi over 2. Okay, so now, and I'm going to leave this to find the equation of the two lines. So this would just be well, I'll just do it, negative, well, the 2's cancel out, so I just get negative pi, and then sine of pi over 2, that's going to be a 1 there. Okay, and then sine of pi is just 0, so minus 0. Okay, and now this will be pi over 2, right? And then cosine of pi, that's a negative 1, minus, and cosine of pi over 2 is 0, right? So here I get like negative pi, and then I invert, this will be a negative pi over 2, and I invert and multiply that. The pi's cancel out, the negatives cancel out, and I get just a slope of 2. Okay, and so that's what the slope of the tangent line is at this point, and that makes sense. If I actually draw that tangent line here, that does, the slope of 2 makes sense, doesn't it? Okay, very cool. So now the slope of the normal line will be a negative 1/2, right? So I'm going to find the equation of the line when I got a slope of 2 and pi over 4, pi over 2 for my ordered pair. So this is the y, so it'll be y equals mx plus b, where m is 2, and then the x and the y are here. So pi over 2 is equal to 2 times pi over 4 plus b. Okay, so this is like pi over 2. And so I bring that over, it looks like my b is just equal to 0, right? And so it looks like the tangent line is y equals 2x. And that makes sense. I didn't draw it perfect. This should have been more like that. Okay, something like that, but it's just y equals 2x. And now for the normal line. So now I'm going to use the slope negative 1/2 because the relationship, so this is the equation of the normal line. The relationship to two lines that are perpendicular, if the slope of one line is, let's say 2, the other one will be negative 1/2. It's the opposite reciprocal. Okay, so now I got to plug in these ordered pairs here, and when I do that, I get pi over 2 is equal to the opposite of 1/2, and this is pi over 4, and then this will be plus b. Okay, so my b is going to be, this is like pi over 2, and this is negative pi over 8, so plus, moving that over to the other side, it'll be like that. And so this is really 4 pi over 8 plus pi over 8, so it's really like 5 pi over 8. So that would make this 4 pi plus pi. So 5 pi over 8. So this is the tangent line. And then the normal line is going to be y is equal to negative 1/2 x plus pi over 8. And that's the equation of the tangent line. And so let's see if this makes sense. One that's perpendicular is kind of like this, I guess. And 5 pi over 8 is 5 pi over 8. Yeah, right, probably right about there. And the slope is a negative 1/2. That would be 2. So that does make sense. So there you go. You got the slope of the tangent and the slope of the normal line. Okay, and then I can zoom in on there and you can double check it there. So okay, I think I'm going to show one more involving these tangent and normal lines, and kind of look at some interesting things with this last one.